Quantity of ethanol was heated until it reached boiling point. Temperature of the ethanol after heating began is modeled by this equation here. Theta is the temperature and T is the time. So it makes sense to use something like theta rather than a capital T even, because then they're distinguished. A and B are positive constants. We're told two conditions: initial temperature, that's when T is 0, the temperature was 18, and after 10 seconds, so T is 10, the ethanol was 44. Find a complete equation for the model giving A and B to three significant figures. So we can sub in. First of all, I'm going to sub in T is 0 to give me 18 equals A minus B, because e to the power of 0 is just 1. We can see where we're going with this. We're going to get some simultaneous equations. And then when T is equal to 10, I'm going to get 44 is A minus E to the minus 0.7. You could write that as a decimal. I'm going to work exact for the moment. Oh, I also missed a B out. So I'm going to subtract the equations. I'll do the bottom minus the top, give me 44 minus 18, which is 26, is equal to A minus A, which is equal to minus B e to the minus 0.7 minus minus B. And this will become B1 minus e to the minus 0.7. Therefore, B will equal 26 over 1 minus e to the minus 0.7. Let's figure that out. 51.647. I'll round it in a minute. Let's get A first. So A is going to be 18 plus that, ends up being 69.647, which means our final answer will be that theta is equal to 69.6 minus 51.6 e minus 0.07t. Then told that ethanol has a boiling point of approximately 78 degrees, use this information to evaluate the model. So we know it's initially 18, it's 44, it seems to be going up. So let's take a look at what happens when t gets large, or as t approaches infinity, because that's going to be happening over the long term. Theta is then going to tend towards, well, the exponential term actually is going to get smaller and smaller, because e to the power of a large negative number, which is what's going to happen, tends to 0. So that means theta is going to tend to a, which is going to be 69.6. And that means it's not actually going to boil. It's not going to get to 78 degrees. So the ethanol not boil according to the model. But we're actually being told that it is heated until it reaches boiling point. So that is actually happening. So basically the model is not reliable or not applicable or not appropriate. There we go. Just a little bit of extra for this equation. And you might even want to think about it at the start, to be honest. Think about what kind of function this is, a negative exponential. So I'm only going to look for positive values of t here, but a normal exponential is like that. When you have a negative there, it's a reflection. Let me draw the tail on. It's a reflection in the y-axis. The negative one ends up looking like this. If we then make it negative here, it actually flips it. So it would look like that. And if I then add a constant to it, I'm just talking about transformations of graphs really, then because we're told it's 18 at the start, it's going to be like move all the way up to here, and that's what it's going to look like. And then it's going to converge towards this value of, I think it was 69.6. So 18 here, we've got 69.6. This is like now more of a comprehensive kind of graph of what's going on. Remember, t starts at 0, otherwise it would kind of carry on like that if you were to draw the whole function. But that's what's going on. And if you can, like, start thinking with these exponential modeling or any kind of question really where you try and understand what's going on, try and think about what the graph will look like, because it can help in situations like this. We got away with it, but I'm just trying to sort of talk about when t is 0, sorry, when t approaches infinity, this is what's going to happen. I can see immediately if I can draw the graph that it's going to approach an asymptote and that it's going to end up being this 69.9.